Hey folks, welcome to another episode of Snapp Tech Podcast. We continue a discussion about SDK with Enrique today. So if you haven't seen the previous episode, take a look. In that one we talked about what is an SDK and a little bit the foundation, what we kind of definition of the terms. Today we're going to be talking more about versioning and installations and sharing and so on. So where do you want to get started?
Well, what is versioning is probably a good start. So generally it's not only something specific for SDKs, but for SDKs it's particularly important. And when we talk about versioning, we talk about giving a name, giving an identifier to our SDKs to know if they are, if they are increasing the version, which they are, but also very important to manage things like breaking changes, which happen, they happen every time you release a new SDK that is not compatible with the previous one. So there are some mechanisms, some systems, some patterns that we can start applying in order to notify to our users, the developers that are integrating our SDK, that things need to change or eventually they can break. Normally, or one of the gold standards that we can apply today are the semantic commits and the semantic versioning. This is something that app developers might have seen also when we're developing an app. And generally, we have three different numbers when we have an application release or an SDK release, right? The first one is the major one, then we have the minor one, and then we have the patch. So typically in an app, you see that, we are releasing the new application, which is 1.10.5. Sometimes we beautify with an identifier at the end that specific build. And there are also techniques that we can use, such as identifying the Unix time. This is always unique. Identifying the amount of commits that we have on a given repository. This is also unique, right? Like the commits are always increasing by one, or whatever suits you or your company or your product.
But in versioning, we usually have two different version numbers. One is the technical version number, and then one is user-facing one, right? So in SDK development as well, we kind of have to keep in mind that the app developers need to understand as humans, and then the computers need to understand the version as well, right? Mm-hmm. So do you separate these two different versions in SDKs as well, or you just use the technical one?
Mm-hmm. This is a very common approach as well. So personally, in my case, it always depends on, the client that you're working with, the product that you're working with. But effectively, as you say, there is going to be the public one that is a readable number, and the other one which does not need to be readable, right? Like the Unix time, of course, you're not going to remember which version is this one because it's just a very large number, but it's a technical one that machines are going to understand better.
They understand that there's a new version and they can then pull an update. Mm-hmm. When we talk about managing breaking changes, it's quite important that we don't, so there's a difference of pushing a patch that fixes a bug and we're relatively certain it doesn't break anything. And then we add a feature. That's a different thing, that doesn't break anything. But at some point, sometime we have to do breaking changes. So we have to, when we distribute, we have to make sure that the receiving computer understands the difference between safe update and non-safe update. How do we manage this one in general?
So in order to do that, I think the best approach is automate everything. Let the machine do things without humans having an intervention. The reason is that humans make mistakes, we make errors, we're tired, we're making a release on Friday at 6 and you're not thinking very much. And the machine, it doesn't matter, it's going to understand perfectly the context. So just automate the entire release flow. This means that you could follow something like the semantic commits and the semantic release, the semantic versioning pattern, for example. Every time you increase the major version, the first one that you have in this three-digit sequence, the machine is going to understand that, okay, this is a potentially breaking change. It's not always a breaking change. It could be that you're changing one single API, but this single API change has the potential of breaking the build, obviously. But it could be that your use case or your application doesn't use this API. So in this case, it's going to work for you transparently. But since we rely a lot of automated systems, for SDKs and applications, we could use things like RenovateBot or Dependabot. They work for every framework. They work for almost every language. And they automatically identify if there is a new version available, and they just send you a pull request, or that you have a lot of configuration options. You could say, just get this merge automatically, which I think is a bad idea, but I've seen this in previous companies. And you could say something like, okay, if it's a fix or if it's just a patch, update it. I'm assuming that it's going to be fine. And if it's a major one, don't do it. Just wait until a human can automatically and read the release notes and see what's going on. Personally, software tends to get complex, and well, it's not the same as small app as a large code base. I tend to like the human as the last resort, as the last commit before pushing something into production. I feel more comfortable when a human is reviewing, especially in this AI era, PRs, versions, updates, even if it's a minor one, because sometimes even if it's a minor one, it could be that this is slightly changing the behavior of your code base, right? And if you just automate everything, we're probably going to be in this slope of AI software, which is like a lot of automated software and generated software being merged. I think there could be some deterioration of our current state of the art in software engineering because
this
of
is also something that the developers who use the SDKs have to keep in mind, and there needs to be a certain communication between the people who built the SDK and the people who use the SDK, saying what is the pattern of versioning that is safe to apply. Android, you can say never update if it's more than patch, right? Mm-hmm. Cradle allows you to do some things like that, right? Now, that's also they need to be communicated by the developer of the SDK. What is my approach to update? So what is safe thing to do? There's not such thing as fully safe thing to do. So the user of the SDK also, when they update the SDK and they re-release the application, they also have to bear kind of responsibility of making sure everything works. But you as an SDK developer, you can communicate to your community saying, if it's 1.2.x, whatever the X is, it should be safe, right? When it's 1.3, you might want to manually go through everything again. But it's again, communication thing. This is a human-to-human thing more than a computer-to-computer thing, right?
Mm-hmm. Exactly. This needs to be always very transparently communicated. Typically, if you have an SDK, you might have documentation, you might have release notes, you might have a README website where you specify how the release process is working, and you need to be open about it. Like expect like a potential breaking change if this is changing or not. And
so I'd underline the thing about what we developers, an early stage of developer career, what we often do is okay, we are nerds, we developers, we deal with computers. But the reality is that we need to deal more with humans, and it's more important to deal with humans than computers. Actually, more difficult to deal with humans than computers. So, is there a difference when you approach building something internal, public? Is there a difference between closed source and open source when you start distributing things? Because when you distribute open source SDK, people can go and look at the code. You can defer some of the responsibility. You shouldn't, but you can. You say, okay, well, the code is there, take a look. You see the PRs, you see all of those things. But say when you distribute something closed source, the responsibility is very different. So if you pull a new Firebase SDK, which is fully closed, right? You have to trust the developer that they didn't actually screw up something. Is there kind of in your mind, is there a difference between open source, closed source, internal, external, and so on?
There is a very different fundamental approach to it. And generally on open source, everybody can contribute. Your code is transparent. It can be audited. So you can get companies to inspect security issues, right? Like if there is any leaks or privacy concerns, whereas on a closed software or a closed SDK, this is going to be managed by people at the company. They know the processes. You don't need to externalize them and be public about them. So the approach to how you communicate the state of your software is fundamentally different. We can be talking about in open source communities, you have these contribution guidelines, and they need to be very strict. Because imagine you start now contributing to, I don't know, any open source library that you like, and you start using your own, modifying the files the way you want, and using like a different commit system. If everybody does it this way, the code is not going to escalate and it's going to start breaking apart, and everybody's going to push their own agenda. So this needs to be stricter for open source libraries. You need to manage things like licensing, right? Like we were contributing recently to some of the Nextcloud libraries, and in one of the pull requests that we created, they come back later and say, please, can you add this license header on this file here, because include your email and include your name. So that's something that, you have another requirements on a private application, on a private SDK, but this SDK is not going to be read and easily accessible for everybody. So all these processes are a little bit different. In open source projects and SDKs, you might have also different standards. Now, especially with the AIS law, we saw recently that many companies and many maintainers of open source SDKs and repositories are becoming a little bit more hesitant to accept external contributions, precisely because the AI, right? It's very easy now for anybody to go and type on your anti-gravity, your terminal, please do this thing, and well, it's code that what happens with Gen AI, it looks very good, it might even compile, but sometimes, if there is not a proper review process, you don't know what's coming in. So
yeah, it's a side effect of this idea that as a developer, you have to have a lot of green dots in your GitHub profile, otherwise you're not the real developer.
Which is a terrible idea, in my opinion.
Right? Yeah. So, okay, let's shift gears a little bit. Still, we talk about distributing. We Android and iOS is very, very kind of clear for us, but we do, of course, we talk about everything in general. But now when you start building software and cross-platform tools, Kotlin multi-platform, anything else that is out there, that changes the distribution a little bit, right? Because now you have to distribute native calls and all of those kind of things and separate in different platforms and so on. Maybe the packaging is a little bit different, but also you have to have messaging to two completely different cultures. iOS and Android have different developer culture as well.
Mm-hmm. It's very different and changes a lot the way you approach the complexity of your code base. The entire multi-platform versus native discussion, I think it could take us 10 chapters and we would not even get started with it. But when it comes to SDKs and distribution here, the approach is that a native SDK is generally closer to the code base, to simplify it very much. And you can generate your native artifact. This can very easily integrate into your code base as an external piece, and you're generally ready to go. There could be always some exceptions. You need some native on NDK code on Android, for example, that you need to repack, etc. But with multi-platform frameworks, this expands the universe of possibilities by a factor. When we are talking about React Native, for example, it could be that we're just, there is this very React Native library written in React Native, and you just integrate into your React Native app. But also the reality is that many of those SDKs still rely on some native packages, native code, because sometimes you just need to do it for whatever reason. I recall a few years ago, I was talking with one company as a prospective client. I was contracting back then, and this company had an application developed with React Native because they wanted to, what comes with React Native is going to be cheaper, you're going to have a single code base, and everybody's going to be very happy. I'm not talking badly about React Native. There are also use cases and examples of integration, but the reality is that this company ended up with an application that was compiling only for iOS. It was not working for Android. And the reason is that they needed to connect with some health APIs and some NFC APIs, and there was back then nothing functional in React Native. On the code, they have some sort of bridge with an SDK that they developed themselves, which was interacting with the native part, and this native part was connecting with Google Health, and at the end it was the worst of two worlds. You have a code base that has expanded into bridges and native code bases, and it's not even working for one platform. And this is something that is very important when you're thinking of an SDK. Yeah. Am I going to offer an interface for multi-platform developers, whatever technology? Am I going to be doing a native one? Am I just creating a native SDK, repackaging it, and providing an interface with a bridge, so my TypeScript developers or my Unity developers using C# or whatever connect directly? Depending on this, the complexity can explode, and ultimately this is bad for your end users.
Right. Yeah. Can we take a bit of an example? I would like to hear your thoughts how to solve the problem, because until very recently, the way Kotlin multi-platform handled, threading or coroutines or whatever you want to call them on this was very different between the platforms, iOS and Android. Right? Mm-hmm. As far as I understand, it's now getting better, but we were a long time in a situation where parallel computing on iOS and Android happened differently on Kotlin multi-platform libraries, right? So how did we as a community handle this? Because Kotlin multi-platform is a pretty good platform to deliver software and libraries. You can deliver SQL libraries, you can deliver REST libraries, you can deliver a lot of things that save a lot of times between those things. But if something as fundamental as a threading works differently between platforms, how do you handle the things? Is it okay to ship a library that has a limitation on one platform, not another? How do you communicate that, and how do you handle this kind of separation?
This is a very good example because back then the background threading model for the coroutines was different, and now they are, the coroutines are essentially multi-platform. Underneath, I think on the iOS side, they translate into completion objects. On Android or the JVM, you get the standard coroutines. But you're right, at some point, you could not offer the same interface to one platform as to another platform. KMP, in my opinion, is one of the best multi-platform frameworks. There is like no silver bullet, so you need to see what I need, what I have on the market. Generally, there is always a trade-off. So multi-platform means you have access to several platforms with a single code base, but you could end up with a trade-off in terms of performance or code complexity or scalability generally. And one problem precisely stemming up from this multi-platform thing is that the APIs are going to look different. For example, if you are using Kotlin multi-platform and you are exporting to Swift, the interoperability happens via Objective-C. So in principle, things like default parameters or name arguments, which are supported on Swift and Kotlin, are not available on Swift using KMP precisely because of the Objective-C interoperability. This can be solved with Ski. I think it's a plugin that TouchLab developed. But again, there is always like this thing that is going to be more detrimental to a specific platform. As a gold principle, the API should always be the same or very, very similar for different platforms. Precisely because you're dealing with a domain and a model and a problem that you have modeled internally, and you're trying to offer a solution. If suddenly you require very different parameters on a platform and many different parameters on another platform, then your problem might start forking, and you might end up with two different problems, and that's not what you want as an SDK developer. That being said, it could happen because there are always peculiarities in one platform or another. For example, if you're developing a KMP library or a KMP application, you might be providing an UI and an interface for your user. And one thing on desktop is that you have the right click, whereas on mobile devices, you don't have any right click. So you might want to have a parameter that is like has right click or something that changes a little bit the interface. But the core of the problem that you're modeling with the SDK should be as close to 100%. Otherwise, we're talking about fundamentals of the code changing.
I also think like the idea of building multi-platform is great, but at some point, if it fails, it fails. It's a tool, right? So when you understand a tool doesn't work, then go native, right? Don't force the tool to work. If it doesn't work, it doesn't work, right? Okay, so I want to ask about stay a little bit still in the multi-platform. When we share documentation, how do you handle multi-platform documentation? Because you have to handle different IDEs, even a mobile you have to handle multiple IDEs. Is there any tricks for that?
Well, if you're using multi-platform framework, generally you can rely on something like, I think KDoc or Doka has support for multi-platform on Kotlin. You could be using the same, generating the different objects. If you're creating different SDKs, it might fundamentally differ, because if they're not native, you might end up with, using Javadoc maybe on your, your Java library, a different mechanism on Objective-C. So that's probably something that needs to be figured out before, at the stage where you are committing code, verifying that APIs look similar. That's something that probably you need to figure out before actually the documentation gets generated, at the point where you are creating new APIs, committing them into your repository, and verifying that things stay aligned.
I assume that's kind of it's a little bit a sign of a maturity of the multi-platform tool as well, right? If it can't handle documentation automatically, it might be not mature enough to do what you need for.
Exactly. This world is also very dynamic, so we see how it has been developing. Regardless of your personal experience, you might always have a bias with because you like more one framework, but all the multi-platform frameworks have evolved quite a bit. So I think we are at the stage where most of them work most of the time, but again, they are not. Is not 100% the way they work. So there is depending on the framework, often performance penalty. There could be a code complexity penalty, as you need like a different build configuration, different setups. If imagine you have your single code base with which is generating like 3 different SDKs, you might have like different build scripts, different processes on your CI/CD. On the other hand, you have one code base or something close to one code base. So again, there is no silver bullet. It's always, I think always when it comes to these decisions, you need to analyze everything, like really make a very detailed study of, okay, what's my platform, my clients, what are the people I'm going to serve with this SDK, what are the relevant APIs, how should I offer them, how am I delivering everything. You just put everything in a Thermomix, in a machine, and you're going to come up with different solutions than another company, because it's something very, very specific. I don't like it too much when you hear these super opinionated opinions about this is the only way to do it and everything else is wrong, because it might be that your way is wrong in a few months because something changed and there is like a new feature kill on one of these multi-platform frameworks that deactivates what you're saying. So it takes a little bit of time to reach this conclusion, but in my opinion you need to be flexible but strict at the same time, if this makes sense.
Well, your opinions need to be founded to something. So opinionated developers are good as long as they okay discussing why. My big communication to everybody, this is beyond just developers, but this is like if somebody asks why, that's not critique to your person. It's about wanting to understand why you approach it this way. And if you can't justify it, then the why isn't very strong. You should be able to discuss that. Okay, I think maybe this is a good place to wrap up. I think next episode I would like to discuss about testing. Testing is very much kind of related. That one, it's a big topic though. So I want to talk about automated testing and what do you do with testing and what kind of frameworks to use and so on, and what are those kind of things. But I think this is a good place to wrap for today. Let's talk next things next time. So I'd say thanks for watching. Thanks for listening, and see you in the next video. Bye-bye.
See you, folks.